Hi friends, and welcome to TRX Bench. Well, today I have here really a nice old lady, so that is a Yaesu FT-290R, and these radios were very popular at its time. So this radio is approximately 30 up to 35 years, and it was a portable radio, so that is 2-meter radio with all mods, so that means with FM, SSB and CW, and yeah, as I said, it was really popular, and so this radio here has of course a couple of problems, but mainly it will not transmit on any mode. So, well, you know, it is always a challenge to do radios like this, because this is not a normal repair. So it is somewhat repair or restoration, and as far you have always the request to repair a radio, it really can become really challenging, because you are very fast into a real restoration, and therefore we have to look what we can do, because I mean, you can imagine that radios like this would really require a complete recapping, and so that really takes time. And so let's first see if it is possible to get this radio back on air, and then after that we can decide together with the owner what this will be at the end. But now, for this moment, let's see if we are able to get this old nice lady fixed, shall we? Yeah, and here's our drama queen right on the bench, and you see it is already connected, and we can hear that the radio receives, but you hear that there is noise. You may hear it in the background. There is noise with a very strong input signal, so that is minus 73 dBm, and you should not really hear noise, so which is telling me that the receive is also not that good. And you can see that we have here our S-meter, which is really at so it is at the end of the scale. You may see it here on the right hand side. So that is not normal, and well, let's see if it will transmit. Alright, and therefore I have connected the mic, and first of all, let's see if it is switching. Yeah, it is switching, of course, so that tells us that obviously our control unit is working in any kind. But yeah, I already can see my test set, and it is reporting really no output power. So let me see that you can see it as well. Alright, and what you can see here is the output level from my signal generator. So that is what you can hear as received signal in the radio, but as I said, with a very low reception, so a lot of noise. so that means we definitely have a bad synod. But anyway, if I now press my PTT, right, we should see output power in this window over there, but you really see at least nothing. So we could ask ourselves, well, is there output power at least? And therefore, because I'm interested if there is at least a little bit, because that may give us indication. So therefore I have my level meter in between as well. And we are doing the same exercise once again. Now it is on transmit, and you see it is at least minus 14 dBm. I mean, that is very, very, very little, but in any case it is just a little bit, and this could be enough to, this level could be fine to drive my frequency counter, just to see if there is the right frequency which is coming out our radio. And yeah, let me check that, because that is also an interesting information. Okay, and frequency counter is connected. So let's check what our output frequency is. So we know that we only transmit minus 14 dBm. So that means the radio, or no, the frequency counter is directly connected to our radio. So with minus 14 dBm we can't destroy our counter. So let's see what we have. Okay, here we are. So we are transmitting 134. I'm just typing it here into my calculator. So we are really transmitting 134.47 megahertz. So that is very interesting, because we have really two frequencies which comes into a mixer, and one frequency directly comes from our voltage controlled oscillator, and the second one is a fixed frequency of 10.8 megahertz. So this two frequency gets you know, mixed, and when I really now add here my 10.8 megahertz, which is, you know, the frequency which will be mixed with the 134, then we get together 147.27, and the radio is adjusted, or the dial is, let me see that you can see it, and I really do not switch my camera off, so no camera tricks, and you see the radio is at 145.28. So that is really close to our 145.27. So, well, that might be an indication, but it is not finally the indication. So what we really need to check if all the different frequencies are available. So in this case, this both frequencies from the voltage controlled oscillator and from our fixed oscillator, and of course we need to check our ALC, if there is all in the right order, and that might be a good start point. Okay, and that you know a little more about what I'm talking about. Here is our schematic, or it is at least our block diagram. And yeah, let me zoom in here a little bit more. I think that might be helpful. So we have down here, let me see if you can, yeah. So here is our voltage controlled oscillator, which goes, then the signal goes then through a buffer and to a switch, and then here we have the transmit mixer, and that means you may see that the VCO is from 133.19, it's not the best copy, up to 137.19, whatever, I don't know. And you have seen we have seen on our counter 134, which is within our range of our VCO, and from the other side we get here through you can see it through an IF amplifier. We get here our fixed oscillator frequency, which is directly connected via this limiter amplifier. It is directly connected to our microphone, and this is a fixed frequency of 10.81. So this both frequencies gets mixed here in this transmitter mixer, and it might be a good starting point to really see what's going on here. So what's going on here with our VCO frequency, what is with our fixed frequency, and of course here our IF amp gets also our ALC ILC voltage. So if something is wrong with our ALC, then of course our IF amp cannot amplify, and then of course our mixer can't work, because we have here the mixer will work, but we have here a band pass, and the band pass filter is from 144 up to 148 megahertz, and you have seen that we only measure a very, very little output power, which is in the range of our VCO, and that might be the reason why our band pass filter will really attenuate our 134 megahertz, because maybe our oscillator frequency or fixed oscillator frequency is missing. Is it because it is not produced, or is here a problem with our IF amp, or maybe is it because our ALC is not working correct, so that this IF amp will not give out an amplified oscillator frequency to our mixer. So these are the considerations, and as I already said, maybe interesting starting point. Okay, so then first let's open our radio, and this side is our battery side, and Oh, here is a test protocol inside anyway, so that doesn't help right now. And you see here all the batteries. I don't know how long this radio was not in use, and I do not really know if these batteries are still good, but there are no signs of leakage, so maybe they are still good. Maybe, I don't know, but that is for the moment in time not that important. So that is our battery compartment, and of course we need to get access to our circuit, and therefore we need to open this lid as well. Okay, I've taken off the screws here on the back, and now you can flip it up, and right, so here is our that is most likely the main board together with the PA, I believe. Yeah, PA was not wrong, because this is, as we already know, a portable radio, and the output power of this radio is maximum 2.5 watt, and therefore it is not really a big power amplifier. So it is here on this board, and I believe so that this here is most likely our power amplifier. So driver, pre-driver and what have you, and here our output circuit, and then we have the connection to our output jack, and this radio has as well that is very nice. You see here internal antenna, which really shows that it is really on a portable radio, so you do not need an extra antenna. All is on board. Right, what you can see is it is really an older type of radio, so we have a lot of wires here inside, and I mean a lot of is relative, because some other radios have much more older radios. So ask Buddy when he is working on his FT-101, and you see how many wires are in radios like this. Have a look on his channel, so then you can see what he's doing on the radio shop, and then you see what it means to have really a lot of wires inside the radio. So therefore this is almost nothing. Okay, now we need to find where our mixer is, and where maybe the oscillator is, and where is our IF amplifier, and then we can start probing. Okay, and when you work on radios like this, you really need to dig for the components you're looking for, and that is what I have done. And if we look down here, this here is our FET, and that is finally our IF amp. So that is where we get our 10.8 megahertz from our oscillator in, and we are interested if the signal is at least at the input. I believe one of these both contacts pins will be the input, and we are interested if our 10.8 megahertz will be present at this IF amplifier. And let's test it let us first have a short view here in our schematic. So our FET, which we are looking for right now, is a Q1010, this guy here. And you see that if we follow along here this line, so I will directly show it to you, we will get down to, we have it in a second. We will have it in a second. So we will go down here to this oscillator circuit, and you see here is our crystal, the 10.8 megahertz crystal, and here this transistor together with the crystal is our 10.8 megahertz oscillator, and this will go straight up here to our FET. And if that will work fine, we need to see our 10.8 megahertz right here. Okay, so I directly show you the scope screen, and I try to get down here to our FET, and let's see if I press now my PTT, and here we have a signal. Very nice. So it is 162 millivolt strong, and it is exactly 10.8 megahertz. So you can see it in the left down corner. So there, oops, the frequency. So here you can see frequency, and here you can see the voltage, which comes here to the input of our IF amplifier. So once again, and as you see, it is exactly 10.8 megahertz. So that means that the oscillator is obviously working, and therefore now we need to check if this frequency finally gets to the mixer. Okay, so my idea was to check if the both frequencies comes to this mixer here. So Q17 and 18 is our mixer, but you know, as I do not have a PCB plan for this radio, and I'm not sure if there is one available anyways, this is not a good idea, because I'm not able to really identify all the components. So I need to change the approach a little bit. And therefore I go back here to the Q1010, our IF amplifier, and we have already seen that we have our 10.8 megahertz here at gate 1, is it, I believe, anyways. And on gate 2 we get our ALC information, so our DC voltage to to adjust here our IF amplifier. And I'm interested what our DC voltage will be. So we need, I'm not sure, because I have not watched out for the datasheet, but I believe that we need here, I don't know, 2, 3 or 4 volts to get full amplification. So therefore let me first check what we have here on our gate yeah, 2, I believe. Yeah, back here to our IF amplifier, and of course now I go and check here our gate 2 for input voltage, and let me see if I can here bring it to my meter. Yeah, so that is the input voltage to gate 2 with or on receive. Now let me switch it to transmit, and yeah, as I said, I believe I do not have these figures, so I should see if I have somewhere a voltage table, but I believe we need here a little bit more than yeah, 2, 3, 4 volts, whatever. So let's see. Now I press PTT, and yeah, you can see with PTT we have 1 volt, and that is really not very much. So that could be the reason why we do not get our 10.8 volt to our mixer. I mean, I do not know if we get it down there, because it's as I already said, a little bit difficult to probe down there. So maybe let me see if I find a voltage table. I don't know if there is something available. No voltage table, so I don't really know. Therefore, let's go down to our Q1014, which is the ALC and a GC DC amp. And first of all, let's see if we have our supply voltage. So this transistor gets supplied by plus 6.8 and minus 6.8. So plus, of course, to the emitter, to the collector, sorry, and the minus 6.8 volt to the emitter. And you see the supply voltage are indicated right here. So we have minus 6.8, and we have, of course, here 6.8, which should be present at our DC ALC amplifier. That is what you can see here, our both supply lines. So let us check this first, and then we go ahead. Okay, down there we have our Q1014. So that is this guy here, our ALC and AGC DC amplifier. And yeah, again, you see how difficult it will be to get down to its pins to check for voltages, and beside that I do not have the pin code right now. So yeah, anyways, only 3 pins, and we should have at one of these pins plus 6.8, and on one of the other 2s we need to have minus 6.8. so let's check what we can find down there. Okay, so I try here to probe one pin here, and you see how difficult it is to get here down to one of the pins, and yeah, here we have one. So let me let me switch on here the backlight, and you see the first pin is 7.6, and if I go on transmit, this pin is changing. Okay, so maybe that is our collector, which directly goes to our IF amplifier, I don't know, but it is going down, so that could mean that our input is positive voltage somehow, I don't know. Yeah, I believe that is a positive voltage, which should be 6.8. It is a bit too high, so let's probe the other pins. Okay, so that is one of the other pins. It is at 0.8, and when I press PTT it goes up to 1.2. Alright, don't know what that is. Maybe that is base. It is a NPN transistor, so that means in that case the transistor would open. So that means when I say open, it will get current can flow, so that is what I mean, which the transistor goes open. It is not that there is no continuity, so that is not what I mean. Yeah, now let's check the third pin. Okay, I'm always losing contact here, but that seems to be the third pin, so it is plus 4.7, and that means we have no minus 6.8 volt on any of these transistor pins, which indicates that maybe we are really missing our minus 6.8 volt, which could be an explanation for our problem. And additional to that, of course, this transistor could be faulty, I don't know. So first of all, we need to verify what has happened to our minus 6.8 volt. Okay, I've decided to take the ALC amplifier out, and what you can see is what I expected a little bit. So this DC amplifier, this ALC amplifier, has already been swapped out some times ago. I don't know when, but it looks not fresh, and you see that it is not the original transistor. So you see that the pins were bent in the right position, and therefore we have here two pins crossing. So yeah, I need to check out first if this transistor is still working, and then we have the same question: what's about with our minus 6.8 volt? And yeah, when we swap it over here, I have of course removed here our battery compartment, because otherwise I was not able to get here down to our PCB. But here, this here is this here of course is our regulator PCB, and here on this PCB our minus 6.8 volt gets generated. And what you can see here, somebody before has cut this wire, and this wire is exactly our minus 6.8 voltage supply. So somebody has already checked out what's going on. I mean, it can be in conjunction with this replacement, because of course the one who repaired it needed to know, as I need to know it right now, what's gonna happening, or what was happening with the negative voltage supply. So, you know, you see, it turns out that it is yeah, really not easy, because a golden screwdriver was already in. Okay, so have a look what has happened. So here my PTT, and have a look. Wow, I have full output power, and as you can see on the left hand display, the transmit frequency is exactly or very close to what we are expecting. And yeah, so what has happened? Let's go step by step. Okay, first of all, I only have this crappy documentation, and you see this documentation is not very nice, and this here is the only PCB overview, and we were searching for our ALC, which is as well our AGC DC amplifier, which is a Q14, and that is what we were looking for, so the 1014, and we went over here and yeah, we found a transistor, and we have taken it out, and we recognize that it was already swapped out, and that was this guy here. But unfortunately it was wrong. It is not the ALC transistor, so that is the driver stage for our S-meter amplifier. Anyhow, so it has been replaced, so that is very obvious. But yeah, when I recognized it, I was of course searching for the real DC ALC amp, and yeah, what you can see here, you see we always have to dig for the components, and let's see if I can make it visible for you. So let's see. So down, you can't see nothing. That is a problem here. I mean, yeah, down here, we have our, or we had our S-meter driver, which we have taken out first, and then I recognized, oh, that was wrong, and I managed to find our DC amplifier for ALC, which is somewhere, yeah, you can barely see it down there, and I've taken it out as well. And when I have taken it out, then I directly have our output power. And yeah, you know, that was what I was already guessing in the beginning, that we may have a problem with our ALC, and it really turns out that it is the ALC. And what I can say so far, the transistor is here, so that is the ALC transistor, but this transistor, as you may see, is in perfect order. It is not faulty. And what we can say as well, it is not anymore the original transistor. So this is a replacement type BC, I don't know, what is it, 168, I don't know, I can't read it really. But what we can say is it has been replaced as well. It is a replacement type, so no problem so far. But when I take it out, in that moment we directly have, as we have just seen it, our full output power, and output power is on the right frequency with which is dialed in here with our frequency dial. So you see we have something wrong in the ALC stage, but it is not our ALC DC amplifier. Alright, so I have put the ALC transistor back in, and radio is receiving, and maybe you can hear that the tone now is quite good without noise. You may remember when we tested it first time, we really had noise in the background, and now it is nice, crisp and clear, so no problem. And have a look here again. The transistor is back in, and it is exactly the same transistor, so that is a replacement transistor as we have seen it. And have a look, transmit on the right frequency, so 2.47, so that means the ALC is now definitely working. So what the hell has been happening? You may not remember, you may not imagine what really has happened. So the guy who put the replacement transistor back in, or replaced it or swapped it out or whatever, really put this transistor wrong way around into the circuit, and that is the reason why transmit didn't work any longer, because you know, transistor wrong backwards in, or changed the pin code or whatever you want to call it, so it was not working. And I just put it in the right way, and immediately it starts working. And as you hear, receive is fine, as the AGC is working now, it's the same transistor, and the ALC is working now with the transistor in the right way in the circuit. That is, you know, golden screwdriver. Okay, now just to show you that the ALC is now really working fine, we have to adjust it to 2.5 watt according our specifications. And when I go on transmit, and now you see I can here really adjust it with the pot for ALC adjustment, and our radio should be outputting 2.5 watt, and I'm just talking, so that makes it not easier, but you see it is working. And that is really the proof that it is now back working. Everything is really fine. I can put it a little lower, so I should do it without talking. So now a little more. Yeah, that is just fine. Okay, so you see all is really fine. incredible, really incredible. Well, and you may remember that our S-meter doesn't work, so that is what we found at the beginning. And of course, if our ALC amp is not working, then we cannot get the needed DC for our pre-driver for the S-meter. And now you see the S-meter is working fine, and as well our power meter. So you see output power is getting out. So this is now back working as well, after I've put, of course, in the pre-driver for our S-meter. So that is now working fine as well. And you see all what was complained is back working. But to be honest, this radio really needs a restoration. It is not only a repair. So this radio is 30 or 35 years, and this radio really needs a recapping and needs a complete alignment and you know, all that stuff. But that is, as I already said in the intro, is a completely different story, because a complete restoration really is completely a different task, and so that needs to be discussed. And to be honest, I do not have the right paperwork, so I do not have the real service manual, so for me it is nearly impossible to do it, because I'm really not able to identify where all the components are, and where I can test and measure, and yeah, that is really a problem. It was really a hard time to find here only this little, in this little portion of the circuit. It was already very difficult to find all the test points and such. Yeah, and once again, that here is definitely all I have. And you get some ideas where you can find what, but without a good PCB layout, where you really can identify where are the parts, what you're looking for, it is nearly impossible. I mean, yes, we have here our cues, and you have seen only with this drawing, I just mixed up the ALC amp and the pre-driver for our S-meter. So that is what we have seen, and that is really because it is not very nice to work with documentation like this. And even here you do only get the main components, but no diodes, no resistors, so you really can't go into you know, this circuit. And yeah, that is all what I have, and therefore it is hard to do. So for me it makes no sense, because it really takes too long. But anyways, the radio is back working, so we have our transmitter output power, and yes, I've tested all the other modes. I do not want to put it now all here into the video, it's already too long. So we were able to do our ALC alignment, and we were able to bring our S-meter back to life. So you see the required wrap has been done, but to be honest, I'm not really satisfied with it, but we leave it as it is, and we talk to the owner, and yeah, he can use it, but yeah, you know what I want to say. Okay, so that's it for today, and thanks for watching. And if that was a little bit interesting for you, please give me a big thumb up, and catch you next time. Bye.